Hello everyone, my name is Pranesh, and in this video I'm going to tell you what happens when the origin is shifted in two-dimensional coordinate geometry, which is commonly known as the shift of origin. The concept says in the XOY plane, when the point of intersection of the coordinate axis is moved to a new point without rotating the axis, the origin is said to be shifted to the new point. Now consider this figure. In this case, you can see these two black lines, which are the coordinate axes x and y respectively. And this point of intersection origin is now being shifted to another point O dash, which is the new origin. So in this case, we have two pairs of coordinate axes, the black ones, which are the old ones, and the blue ones, which are the new axes. And the coordinates of O dash, which is the new origin, are h comma k in the old coordinate system or the black one. So I am shifting the origin from point O to point O dash, which is h comma k. Now let us consider a point P, this point, and let its coordinates be small x and small y in the old coordinate system. And in the new coordinate system, the coordinates of the same point P are capital X and capital Y, shown in the blue color here. Now our task is to get a relationship between the new coordinates capital X and capital Y and the old ones small x and small y. Now I've redrawn the figure here so that we can start deriving. Let's start with the horizontal ones. Now from the figure you can clearly see that OE is equal to small h, OA is equal to small x, and EA is equal to capital X. Hence, I can also write OA as OE plus EA by geometry because points OE and A are collinear. Therefore, OA, which is equal to small x, can be represented as OE is which is small h plus EA, which is capital X. Therefore, I have now obtained a relationship between the new and old x coordinates, which contains the x coordinate of the shifted origin as well. Let's do this for the y coordinate. Again, OF is equal to k, which is the y coordinate of the origin. OB is equal to y, or small y, which is the y coordinate of point P. And FB, which is also equal to O dash D, will be equal to capital Y. Again, since points OF and B are collinear, we can write OF plus FB as OB, which gives us small y, which is OB, equal to OF, which is small k, plus FB, which is capital Y. Therefore, we have now obtained the relationship between the new coordinates as well as the old coordinates. And these include the coordinates of the shifted origin as well. Now, one thing to keep in mind while shifting the origin is that all of these capital X, small h, capital Y, small y, and small k, these are directed distances or coordinates. So they can either be 0, they can be negative, or they can also be positive. But irrespective of the sign as well as the magnitude, these relations are true. So even if h or k or any one of these is negative, it doesn't matter. All you have to do is simply follow the formula because this is the one which we have proved just now. Let's now solve a problem based on this. If the origin is shifted to the point 3 comma 4, find the new coordinates of the following points 5 comma 6 and 2 comma 2. Now we have got the relationship, uh, and this is that capital X is small x minus small h, capital Y is small y minus small k. Okay. Now the origin is shifted to 3 comma 4, hence h comma k will be 3 comma 4. For case 1, which is 0.5 comma 6, small x will be 5 and small y will be 6. Now using the formulas, the new x coordinate will be small x minus h or small h, which will be 5 minus 3, and capital Y would be small y, which is 6, minus small k, which is 4, which will also be 2. So the new coordinates will be 2 comma 2. Now let's consider another case. Now in this case the point itself has coordinates 2 comma 2. Now as we did for case 1, the x coordinate capital X will be small x minus small h, which will be 2 minus 3, which will be minus 1, and the new y coordinate will be small y minus k, which will be 2 minus 4 or minus 2. Thus the new coordinates are minus 1 and minus 2. Okay, now let's try to verify our answers. We have shifted the origin to point 3 comma 4, which is the blue dot here. The x coordinate is 3 and the y coordinate is 4. The first point is 5 comma 6. Now it is easy to see that if 3 comma 4 is the origin, the x coordinate of 5 comma 6 will be 2 units or 2 in the positive x direction, so it will be positive, and so will be the y coordinate, which will be 2. So the new coordinates 2 comma 2 are correct for the point 5 comma 6, the green dot. Now consider the orange dot, which is 2 comma 2. Now if this is the origin, then this will be negative x axis, this will be negative y axis, so this will be the third quadrant. Also, this distance is 1 unit, but being in the negative x direction, this has to be minus 1, so the x coordinate is minus 1, and this distance is also is 2 units, but since it is along the negative y axis, it will be minus 2. So both these answers are correct using the formula which we obtained, and we verified it using the graph. Okay, so what did we learn in the new video, in this video? We saw that coordinates of each point on the xy plane change when the origin is shifted, and by how much amount do the coordinates vary depends on the shift the coordinates of the new origin, and that fixed relationship is given by capital X is equal to small x minus h and capital Y equal to small y minus k, where h and k are the coordinates of the new origin. Now, why do we do this? The shift of origin is very useful in solving problems on locus. Let's see how. Suppose you are given this equation 2x squared plus 2y squared minus 2x plus 2y minus 1 equal to 0. Now at first it is slightly difficult to visualize this because when you read this there is nothing specific which comes to your mind. But if you shift the origin, this equation will get transformed to capital X squared plus capital Y squared equal to 1. Now this is easily recognizable, which represents a circle with radius 1 and the center at the origin. Now this happens when the origin is shifted to 0.5 comma minus 0.5 minus 0.5. Now this is the figure. This this blue circle is represented by this equation 2x squared plus 2y squared minus 2x plus 2y minus 1 equal to 0. Now note that its center itself is 0.5 comma minus 0.5. In other words, if I shift the origin from this point to this black dot, this equation gets transformed to x squared plus y squared equal to 1, and that 1 being the radius of the circle. So, shift of origin has extensive use in the analysis of various problems on locus. Now, in the next video, we will try to cover the rotation of axis. I hope you understood what I explained just now. If you want more, you can contact me on this email ID. And don't forget to hit like to the video and subscribe to my channel. Thank you.